Hey everyone, Eric here from Iowa Robot Fighting. So the next few videos are going to be relatively short. I don't have anything major to go over. We're going to go through some minor stuff, all the upgrades, and talk about what's coming up in the future for Iowa Robot Fighting. So first off, you'll notice if you look closely, you might notice I'm wearing a different shirt. We are now offering merch for Iowa Robot Fighting through bonfire.com. And if you look at the website here, we've got a variety of options. Evan's favorite right here is actually the football jersey style, which he really enjoys. I like the simpler ones myself, but whether you're an actual Iowa robot builder or just a fan of Iowa robots or just someone trying to support the group, we appreciate you picking up one of the shirts. They are rather comfortable and more of a subdued design than the ones we had originally picked up. And if a shirt isn't your style, we also have mugs and other merchandise. So go check it out. The link is in the description below. Last time we spoke, we talked about a variety of different materials that needed to be changed over on the robot. One of which being the armor. We have been looking into the different armor types, and for myself, with Cowboy Beep Boop, which I will be keeping the name of right now, I had this aluminum armor in the front. I am starting to look into, you can tell the difference just in the sound, can't you? That sounds chintzy. That sounds strong. This is a steel plate. Same thickness as the aluminum, as you can tell. Exact same thickness. However, this steel plate weighs about twice as much, a little more, than what the aluminum does. It has a lot better impact characteristics and will serve me a lot better as the front wedge of my robot. However, that means I need to cut down on weight elsewhere and try and make other options work. Future videos, I will be trying to shape this into armor, but early tests have indicated that you can shape it just fine. Armor panels aside, though, the previous wheels were made out of this low diameter neoprene, and I don't think I'm saying that right. Durometer. It's all based on the density. There are three different ratings of density of rubber and material. Those are called Shore or diameter ratings. Shore OO, A, and B. From what we've determined, this is a Shore OO 40. So what that means is that it's very pliable. And we'll pop up some video here to show you Evan's robot running around. You see the wheels warping a little bit. And when he sits still right here, you can see the wheels are bowed out. And that's not exactly what you want. It makes it difficult for his robot to get going again if it's not riding up on the center of those wheels. So we've started looking into other materials. This is Shore A50. This is also neoprene, same deal. However, it is much more dense, and you might even be able to tell just by the nature of it. This is rubber. This is just a sheet of rubber. Now, cost-wise, and that was the whole point of building our own wheels in the first place, an entire sheet of this, which was almost double this amount of material prior, was $20. This little strip was $25 by itself, which means we can't get many wheels out. It's still a reduction in price over going with finger tech or anything like that. But the problem being, and I'll show you the numbers here in a second. This material is what we originally had for our wheels, and you can see how much that flexes. And this is the the Shore A50. And you can see I can barely flex that, which means it'll ride up on its edge very nicely for larger wheels. Problem is the weight difference. The original Shore 0040 is only 5 grams for our standard size wheel. The Shore A50 wheel is 50 grams by itself. That's 10 times the weight, which means 2 wheels for Cowboy Beep Boop or 2 wheels for Horns of Jericho would end up eating into almost a fourth of the weight allowance for the entire robot. So these are unlikely to work. This material will likely work well for 3-pound robots because it'll be extremely durable. I mean, I think I haven't even tried, but let's take a look at cutting into it. So I can cut that no problem, right? But cutting into, I can barely scar that. It's amazing. It's great. The other issue is that our hubs were designed with the pliability of the Shore 00 material. So these are nearly the same thickness. As you can see, there's a little bit of difference in them where my thumb is here, but not much. So I could feed the hub through just like that, squish it down, and put one of these top plates on, and it would hold it in place just nice as could be. Because it's not as pliable, I not only had to widen the hole, but I'll also have to elongate that that central part of the hub. There's a lot more that needs to be done with these hubs though. The tolerances have to be tightened up. There's a lot of different things. There's also a way we might be able to utilize this if we created a larger hole and made these hubs bigger. It would reduce the overall weight. The 3D printed material would take up a lot more of the surface area, and we would have a cross between the durability. We might be able to cut 50% of the weight off this and turn these into 20 to 25 gram wheels. Looking into that as an option as well. So durability is a big bonus, but we're also going to get another strip of this, probably looking into Shore A30 or Shore A20, which should be double or triple the density of this rather than the 10 times density increase as well. So we're going to continue to play with materials when it comes to the wheels. Another material we're looking at is a material known as UHMW. So UHMW is an acronym for ultra high molecular weight, and that's an acrylic that essentially is just saying that is highly dense. But it is still really light. Problem with the shipment that we got, and we decided to go with thin panels, and what we could do is we could cut strips of either one of these pieces and create outer armor with it, which is an option, and we probably will do that for certain designs to test with. However, the warping makes it really difficult to create a nice, cohesive, full chassis with it. You can see that I did 3 different cuts here. So this is basic acrylic, which is about double the thickness, but also double the weight of these 2 pieces. These 2 pieces come in at about 2 grams each, which are 1 inch by 1 inch squares. And then this is also a 1 inch by 1 inch square. So acrylic, polycarb, and UHMW. All of which weighed 2 grams with the exception of the acrylic, which weighed 4, but you know, it's double the thickness, so that's forgivable. And what that tells me is that I could make a complete robot out of UHMW like we attempted to for Evan's original Horns of Jericho, and end up with a really strong yet light robot. The problem comes in that we need to order large blocks of UHMW and then find a way to mill it. So another member of our Midwest robot builders community, which I'll pop up his name here, came up with a way of doing hand milling of a robot chassis out of a block of UHMW, which you can see an early attempt right here, and then his later attempt here. We're going to try and mimic that. Once we get on our UHMW blocks, we'll be doing some different techniques in an attempt to get a nice clean chassis and potentially be able to create a complete cowboy beep boop chassis out of UHMW as one solid block, which would be excellent and not exactly all that expensive. Each block is roughly $10 a piece, $5 depending on the size, and we should be able to make each chassis for about $5 to $10, which wouldn't be bad at all, and it would be just as durable and light as the UHMW sheets. There's other options, but they all require the block. And I need to do some full redesign, which a future video will be coming in to show what the plan is for the new weapon for Cowboy Beep Boop. The last option for chassis is a 3D printed material called NylonX, which is just a proprietary name for nylon filament with carbon fiber in it. There are plenty of instances in which people have used NylonX for applications that required high durability and high strength, which is great for combat robots of all the way up to 30-pounders. We've seen a video of people building internal components for 30-pound robots, so if we could build an entire chassis out of NylonX, that would be great. The problem comes in that most printers can't print NylonX as a base configuration. One of the things you need to change out is the brass feed nozzle or extruder nozzle, which I'm changing out here, which is tool steel is what we're going with for that. It will keep it from wearing down because NylonX is abrasive because of the carbon fiber in it. The other end of things is that you typically have to replace the hot end of your printer. This is where the extrusion nozzle actually attaches, but in regular printers, in most printers, there is a section of it that is plastic that makes contact with the hot end, and because NylonX has to print at minimum 250 degrees Celsius, it melts that hot end and you end up with slag instead of a printer. So those items weren't all that expensive. The entire upgrade for that end of things ran me about $30. Not a big deal. The other thing is I need to acquire a sheet of glass to print on rather than my textured bed. That is yet to be acquired, and I still need to get the NylonX. I'm not certain I'm going to go this route because just a half kilogram of NylonX is $55. It's really expensive, and if I can find another option, I will. And because printing takes a long time, I'm not certain it's the best option. However, the durability is really high, and one of our competitors at the Minneapolis competition actually was running a NylonX chassis and did really, really well. I was very impressed. So all that aside, we have a lot of work ahead of us to make both Horns of Jericho and Cowboy Beep Boop capable of winning at these competitions on just materials alone. As we get more materials in and as we start doing more testing, we will be pumping out videos every week to show you our progress. The next video will likely be a cross between testing of weapon configurations, possibly testing some of the new materials, and also we're working on getting the acquisition of the steel we need, the hardenable steel. to be able to forge our weapons, which will be one of the more exciting videos we'll have to offer. Since we're getting into fall now, it'll be nice to be able to run the forge in cool temperatures and not have to sweat our butts off. That aside, we also are starting to approach the local universities and hobby stores about helping out and possibly getting involved in the Iowa competition. If you're in the Iowa area and want to be a part of future competitions, we are looking to hold one in the Des Moines area or the metro. If you're a builder or an aspiring builder, don't hesitate to reach out and ask questions. We have a Discord channel that we'd be happy to invite you into if you're interested in being a part of the local robot community. Additionally, the Minnesota group, a Wisconsin group, and an Illinois group are all getting together with us to start working towards putting together a Midwest League, where we will do one fight, one competition per quarter in each state. Starting next year, hopefully we will have something akin to the start of a major league in the Midwest and start bringing together all the 1 pound and 3 pound builders that we can with a traveling league that is up in Minneapolis, down here in Des Moines, hopefully up in the Milwaukee area or Green Bay, we're not sure where, and probably not in Chicago unless we find a decent location for that, but that is up to the Chicago/Illinois group and their endeavors in that area. I'm hoping that everybody is having as good a luck as we are approaching people here. They are very receptive, especially when we bring our robots in and show them how cool everything is. Evan had some great luck talking to a group in Ankeny, and if you guys are tuning in, thank you so much for having us. We look forward to meeting with you again, and I personally look forward to meeting the owners of the hobby store that Evan visited just recently. With that, everyone have a great week. I will catch you next time.